Hello, everyone. You're listening to Through Time and Clays. My name is Joan,
And I'm Albert.
and we are back for another news episode. Um, we are actually recording about uh, a week from our last episode that we recorded, the Doraemon review. But we are back, and we realize that we've been busy, we've been working on things, so we've kind of missed the last couple of months or so. So we're going to do another news episode where we cover 2 months worth of stories. So we're going to be covering April through May of 2023. But before we do that, Albert, how you been?
Oh, let me think. I guess I don't have too much new to report. I hope everybody enjoyed our last review episode where we talked about Pleistocene megafauna and first humans in Japan. That was really fun to do, and of course, celebrating a Japanese cultural icon, which was a big part of my childhood. Um, but otherwise, things have been pretty much the same for me. I I know we mentioned this briefly last time, but Prehistoric Planet, of course, the second season came out last month, and we didn't go into much detail about our thoughts then, and I don't think we really will now. But I do have a slight update to make to that, is that I ended up writing a review of it on my blog, discussing the parts I liked, the few small criticisms I had, and essentially, well, what science was probably used to inform some of the notable segments in the show. So I'll be sure to link that in the description below. But other than that, I think things have been pretty much the same for me. How about you?
Yeah, not too much to add, really. I mean, besides working on the show, I've been just doing the same old around the house. I started a new book. Well, I say new book. It came out in 2007. Um, but
New for you.
so I've started reading Callum Roberts' The Unnatural History of the Sea.
Oh.
Now, this is one that's been on my to-read wish list for many years, ever since I had learned about it from Darren Naish. It was one of the Tetsu podcasts that they did,
Oh. Hmm.
and he name dropped the book and how interesting, also kind of depressing it was. Um, so I'm like, well, that sounds like an interesting resource. I'll
Mm-hmm.
I'll look it up. So I had it on my wish list for a while, for like many years, and then I finally got it like last year, and now I'm finally starting to read it. So
Yeah.
it's been like up in the air, like they're waiting for me for whenever I had the itch. Um, and then what was it? I was watching a PBS documentary about Cuban wildlife, and they were talking about the parts of Cuba's coastline that haven't really felt the weight of like industrial intensive fishing and that sort of thing.
Mm.
So they're still relatively fertile. And my mind went back to this book, and I'm like, well, I have this book. I might as well finally read it. And I've just started. I'm a couple chapters in. Basically, what it is it's an account of the defaunation of the ocean, and kind of the origins of the human practices that got us up to this point. Um, and what's kind of surprising is that you would think that, oh, well, that's only within like the last couple hundred years of industrialization, right? When things were getting bad. It's like, no, no, like some of these practices date to like medieval Europe, and kind of the shift from the freshwater ecosystems to the seas and then to the oceans, that coincided with the um, change in land use practices in Europe that led to the kind of reclaiming of the forests, and then the subsequent like pollution and disruption of the river systems, which kind of lessened the aquatic faunas there. And so people were having to kind of shift focus elsewhere, and they went to the sea. And with improved um, navigation methods that were probably introduced by the Danes, um, they quickly started to make work of the oceans that way. And of course, carrying these along into the Americas and beyond. So like I'm not very far in, but already it's really intriguing, the evidence that we kind of have, and the discussions about the shifting baselines,
Mm. Yep.
where like if if you're born and you look around at the natural world, and you don't know any better, you would think that, oh, this is how things are in nature. But then just a couple generations ago, like things were much more rich and diverse, and not so contaminated
Hmm.
by human activities. And then you go further than that, and it's even more so. And so, like, there's this kind of like cultural amnesia that happens every couple of generations where we forget just how rich and and full the oceans were,
Mm.
um, until relatively recently. And so to see the book kind of explore that and talk about, how big certain fish used to get and just how many there were, and some of the, although colorful, like probably accurate, in context descriptions
Yeah.
from like fishers and sailors talking about, trying to get their boat through the water, and this just covered in fish. It's just wall to wall fish everywhere, and just all the turtles and whales that there used to be.
Mm.
um it's incredible. And also it's nice to see this in the context of like some classic stories that I know about, like the extinction of the Steller sea cow,
Yeah. Mm.
which opens the book. um it really gives you the context for why that happened. Like this crew, this Russian crew that was stranded on the island, and they were so hungry that they just kind of made quick use of all the resources, and everything else kind of like got used to their behaviors and was kind of hiding away and
Mm.
being more difficult to catch. And so they were like, wait a minute, we have these giant floating things on the coast. Let's just eat those. Um, and then just the scale of the killings and just how quick it was, um, just fascinating and sad. Um, so who knows? Maybe I'll talk more about this book when I finish it. Certainly, book reviews are not um, foreign to the show. But yeah, Colin Roberts' Unnatural History of the Sea. Um, so far, it's fascinating, and we'll try to put a link in the description if you want to find this for yourselves. Um, so I would certainly recommend it already, but that's all I've really been up to lately.
Yeah, that sounds like an excellent book. I haven't read it myself, but it definitely sounds very intriguing, and the subject matter is very important. Um, so we'll definitely pop a link in the description so everybody else can check it out too.
Yeah, absolutely. We do have a couple of fun announcements that we wanted to introduce, things in the world of natural history that might interest some of our viewers. So let's go ahead and jump to the next slide, and we can start talking a little bit about that.
Mm.
So we have a new book that came out relatively recently that I think is going to be on a lot of people's attention if they're interested in paleo art, which is the process of using scientific data to reconstruct prehistoric organisms and environments, um, to the highest scientific accuracy, while also maintaining like traditional like wildlife art methods. And this is kind of the sort of stuff that you see in like museums and science books and media that is, at least as informative as can be, like Prehistoric Planet, for example. And so, kind of one of the giants in paleo art history is a man, Zdeněk Burian, who's a Czech paleo artist who was active for pretty much almost the entire 20th century. He has been incredibly prolific, producing seemingly thousands of paintings for hundreds of books on any matter of subjects relating to paleontology. I believe his first paintings were from like 1921, and he was active up until like the early 80s before he passed. So, like, he was around for like sort of the great transitions in understanding for paleo art and paleontology, which must be fascinating. If only we could pick his brain more about this sort of thing. Um, but yeah, I mean, he has been the, I guess what you can call the illustrator for many now classic works on Earth history. Some of you may know some of his collaborations with paleontologist Joseph Augusta in the 50s and 60s. And then there's his book, Life Before Man, which is from 1972, which was written by Zdeněk Spinar, and they've had an updated edition since then. And then there's this 1978 book, The Dawn of Man, with Josef Wolf. That's a personal favorite of mine. Features a lot of his hominin works because he had painted a lot with hominins. And of course, his art influenced generations of people. Uh, Two examples that come to my mind immediately are Carl Zeman, who was the Czech director of one of my favorite paleo films, Journey into Prehistory,
Oh,
from
yeah.
1955, about the four boys who sail down the river of time. And the art direction is really beautiful and intriguing and weird. But a lot of the animals in the film are based directly from Burian's pieces, to the point where like I can pick a specific painting and say, okay, they looked at this painting to make this animal. Um, and maybe that's a film that we'll talk about in a future episode. I'd certainly love to. But of course, if you see this Tarbosaurus here at the far left, um, you might recognize it
Hmm.
because that pose has been reused all over the place.
Yeah.
Most notably in Ryan North's ongoing dinosaur comics,
Oh,
um,
yeah.
which I think the character is supposed to be a Tyrannosaurus,
Yeah.
but like that's Burian's Tarbosaurus. Like that is so obvious. Um, but like you can kind of see these paintings, despite their age in some instances, they've had a big staying power, and so and he's widely regarded as like one of the greats, one of the most influential paleo artists in you know paleo arts short history, up there with like Charles Knight and Rudolf Salinger, Robert Bacher certainly. Um, and so there's been kind of a lamenting going on that Burian has actually not yet received uh, the treatment of having new books to celebrate his art history
Hmm.
like Knight or Salinger had. The closest thing we'd had to hint at this was Zoe Lascance's book Paleo Art from 2017, which had a whole chapter on Burian. And it was actually one of the first times that his previous work had been kind of like rescanned and rephotographed with modern methods on like good quality paper. And they really reveal a sharper quality than any of the previous books that he had worked on in the past, to the point where like you could take like say Life Before Man and like juxtapose a painting in that to one featured in the paleo art book, and you can just see the difference in quality, um, making out like the painting marks and everything.
Hmm.
Um, and so like a lot of paleo artists and paleo people have been like, well, when are we going to get a Burian celebration of his art? It hasn't been anything like that yet. Well, now that time has finally come. As you can see in the image at the far right, um, we have this book, The Prehistoric World of Zdeněk Burian, and this is volume one, from the creation of the Earth to the extinction of the dinosaurs. And so this basically covers all of his art, or at least the art that they were able to find, um, that he had done covering the Precambrian, the Hadean eon, until the end of the Cretaceous. Um, and so that amounts to about 400 images across 600 pages. And that includes not just his finished paintings, but actually a lot of concept sketches and notes from his personal desk. Um, and so, like, this book was published, I want to say earlier this year by a Czech publisher called Albatross, with one S,
Right.
uh, with written contributions by Andre Mueller, uh, Boživoj Zaruba, Martin Kostak, and Rostislav Walika. So they have put in the work to collect all of this artwork and rescan it from, oh, goodness knows how many books and scientific papers and exhibitions that Burian had contributed to, which makes it really comprehensive. Now, as you can guess from the fact that I say volume one, um, there are supposed to be two other volumes like in the works to kind of complete the set. Um, and based upon what I've been able to research about this book, volume two is going to cover all of his Cenozoic work. And well, I should say like most of Cenozoic wildlife art. So like everything he did with like mammoths and mastodons and Cenozoic mammals. Um, while volume three is going to be his paleoanthropology pieces, which that'll certainly be exciting.
Mm-hmm.
He was very prolific with hominins. He did a lot of like now classic pieces with like Neanderthals, for example, where we were still kind of in that period where we weren't sure how they were built physically. And so you had, for example, the kind of the sloping, kind of apish appearance to the
Right.
Neanderthals, where the head's kind of positioned a little bit forwards than it actually was in life. Um, and so there's plenty of that, along with like a lot of stuff with Neolithic cultures in Europe. So it should be really exciting. Um, Now, of course, if you're wondering, like, well, this is a 600-page book, how big is this thing? It's appropriately sized. If you think of the Paleoart Lescance book, um, goodness knows that that's a table in and of itself, much less a toffee table book. This is a little bit smaller than that, but I think it's approaching 4 kilograms in weight. So it's a brick. It's a pretty good sized brick. Um, and I believe in Europe, they have this first volume for 99 euros. Um, and in the States, that's $130. Um, so I can imagine to collect the whole set would be an investment for
Mm-hmm.
sure. Um, but certainly, like if you are deeply passionate about paleo art history and are looking for a place where all of Burrian's art can finally be brought together and appreciated, I think this is going to be something that's exciting for a lot
Right.
of people. I certainly look forward to like taking a peek at it somehow, because I know that even though they have some of the chapters online in English that are translated for people to read already without having to buy the book, there are no plans for like an English or any other language release. It's all
Mm-hmm.
going to be in Czech. Um, so you'll probably have to find some way to translate that if you are not a Czech speaker.
Right.
But certainly the artwork will probably speak for itself because everything is like labeled and whatnot, like when the paintings were made and so forth. Um, Now, we'll post a link to where you can buy that for sure. And we'll also link a write up about the book if you want to learn a little bit more about it from a paleo artist and paleontologist, in this case, Dr. Mark Whitten.
Mm-hmm.
He's written a really great article about this. We'll post that as well. Um, yeah, this looks really exciting, and I'm glad that we're finally at this point where Burrian can get his due treatment
Mm-hmm.
in the world of modern books. What do you think, Albert?
Yeah, I completely agree there. It is fantastic that such a book like this exists now. Well, I should say that presumably, eventually, such a series like this exists now, because it is true. Burian is absolutely a major icon in the history of paleo art, and I'm definitely familiar with essentially all of the pieces that are pictured on here. And I can't remember when I first saw them. Um, they're just they've just been such a fixture in paleo media for so long. I definitely look forward to hopefully checking out a copy of one of these at some point. And I also really hope that eventually we might get an English translation of these books, like fully, so those of us who don't speak Czech can also appreciate the text for what it is.
Oh yeah, for sure. So I think right now the best option is, and I told you about this. Um, you can use the Google Translate app if you have a phone with that capability
Yeah,
to uh, take pictures of the text, and they'll translate it, in Google Translate fashion. It probably won't be perfect, but you might be able to get the gist
right.
of what the authors are talking about. Because goodness knows, I mean, I love looking at the artwork as much as the next person, and that's probably like going to be like the main thing that will draw me to a book like this. But I mean, I like that background information.
Mm-hmm.
Um, I kind of want to see like what they have to say about Bury and his thought processes and his history and his collaborations.
Exactly.
Um, in the way that like Charles Knight, for example, has gotten the treatment. Uh, it's pretty easy now to like get the biography of Charles Knight and learn about museums he hopped across and how his daughter helped him out and that sort of thing. His trips to the zoo for wildlife studies. So I'd love to see that with Burian.
Mm-hmm.
Because I understand it, like the little that I know about Burian, he was never really actively involved in paleontology. He was never like going to museums to look at the fossils and then use that to inform his artwork. he was looking through like publications and journals and painting from those. Um, so it's kind of like a different way to do paleo art
Mm.
when you don't have the availability of resources. Um, so goodness knows, I'd love to learn more about that and how he was able to paint the way that he did.
Mm.
Because I mean, obviously, like we look at these paintings on the slide here, the brachiosaurs in the top in particular, and like, oh yeah, like that's from another time. Obviously, we don't see these animals like this anymore.
Mm.
Um, but at the time, these were very cutting edge, and they were widely celebrated and widely distributed. As you said, Albert, I mean, I grew up with these in many ways, um, uh, and there were artists for like children's books and others that would copy from Burrian's pieces and, and kind of use those animal designs for their work.
Right.
Um, I believe like his Hororachus, for example, his terror bird, um, that color scheme
Yeah.
that he used it was borrowed from a bunch of artists. It's called a paleo art meme.
Yeah.
Um, and I think like the Archaeopteryx too here from the
Oh, yeah.
bottom, like that sort of green and blue and brown color scheme was borrowed a bunch. Um, so yeah, he has staying power for sure. And like again, like this is something that I think we've talked about here and there. As much as these images are inaccurate today, like there's a beauty and a charm to them that I always come back to, and like they can be appreciated in like an art history kind of
Oh,
way,
yeah.
um, as I think most everyone else does. Because I know for some people, like some Burrian's pieces represent some of their favorite pieces of paleo art,
Mm.
um, because he was as much focused on the backgrounds and the landscapes as well as the animals. So unlike like other paleo artists at the time that he was working, who were just focusing on centering the animal, maybe to the detriment of like the background elements, he was there like drawing every leaf and every grass and every plant, and making sure the animals looked like they were in nature, like in their environments. Um, which is funny because for the majority of his pieces, he never really depicted animal encounters.
Right.
Like it's maybe like a handful of pieces where like you have like two dinosaurs facing off, for example. His piece with the tyrannosaur and the hadrosaur is uh, probably the best example of this. But for most of his art career, he was just drawing maybe like one species itself, just in its environment. He wasn't really interested in drawing interactions, it seems, uh, which is interesting. So yeah, it's just details like this. Um, there's certainly a lot to say about Burian,
Mm.
um, but we must move on. Albert, I do believe you have an announcement for us as well on the
Yes, I
next slide.
do. Before we go to that slide, I just wanted to add that the black and white coloration of Burian's Forest Rocos that you kind of alluded to earlier, that was incorporated into one of the Doraemon movies to say something relevant to our previous episode. So if that doesn't tell you something about the reach of Burian's work, I don't know what does.
That's incredible.
Yes. Yeah, maybe we'll review that one someday. But as for now, uh, I do have a quick update to make that's also related to another episode we did, a much older one. And this was actually a very last minute addition to our recording today because I learned about this like probably no more than half an hour before we started recording. Um, but yeah, another friend of mine made me aware of this. Is that there is a website called Flashpoint Database, which has kind of taken up the duty of archiving old online games and animations that have gone defunct for various reasons. In some cases, maybe because the website has gone down. In many cases, it's probably because the actual software the games were built on don't work on modern browsers anymore. We know that this is a pretty big problem with Flash, for example. And as we mentioned in the episode that this concerns, I think it was last year when we did our episode on defunct paleo websites that we used to visit but aren't available anymore for one reason or another. Yeah, there used to be quite a lot of old paleontology related games out there. And many of these have since been lost essentially from their kind of original home pages. And in many cases, this is indeed because the factors I mentioned earlier, either the website stopped being maintained or the software no longer is no longer supported by current browsers. And certainly that's the case for the examples I pictured here. But very fortunately, it turns out that Flashpoint database has archived many of these games, and I literally just found this out. So of course it hasn't only archived Paleo games, but many of the games that we talked about in that episode are included in this database. And now I haven't tried this out yet, but my friend who told me about this uh, has at least he's tried out the game on the bottom, Off-Road Velociraptor Safari, on this database, and it works. So apparently the way that this works is that you download essentially a software package from the Flashpoint website, and through that package, you basically install it on your computer, and you can access like any of the games and animations that are available in its are archived in its database. And so essentially, you can pull up any of these games and play them whenever you want, at least in many cases. So from what I've heard, some games are archived, but they're not necessarily in a playable state for some reason or another. But for many of these, and in fact, this is true, at least according to the listings on the website of all the ones I pictured here. For many of these, yeah, you can access them through the Flashpoint software, and apparently you can play them on your computer. So that's really cool, and that means that a lot of these games are no longer like completely lost media anymore. It means that they are now accessible again, which is wonderful. And so the examples I have used here include a couple games that used to be on the old Walking with series websites, and we talked about these. So things like the Sea Monster Adventure game, on the top left, or like the Skeleton Jigsaw game from the Walking with Beasts website. And also a different game that's not affiliated with the BBC is the Off-Road Velociraptor Safari, which is just a very wild concept for a game, because essentially you're playing as a velociraptor driving a jeep, trying to run over other velociraptor, and then sending them through a time portal into the future to make velociraptor tacos. See, I do not know where people come up with these ideas, but that was a thing, and it was surprisingly pretty fun from what I remember. We certainly talked about that back in the episode, so I won't go into too much detail. But yeah, it's pretty cool. And also, you might notice if you stare hard enough, the Velociraptor in this game do have feathers, so they were keeping up with the science back then. So yeah, very cool. So I'm very happy that these games are now available again. And I took a very quick look just to search up some of these most iconic games I remembered. But the database is massive, and so I'm sure that if you look up many of these old online games that you might remember that have since gone defunct for whatever reason, you chances are you will be able to find many of them, and that is very great. So I'll definitely leave a link to the Flashpoint website in the description below. Do you have anything to add?
Well, I think that this is great. First of all, I'm a huge believer in archiving
Mm-hmm.
materials. So to learn that there's a whole like website dedicated to doing this, even for something probably as trivial as like online flash games,
Right,
I think that's great. That's fantastic to hear, and I'm glad that a lot of these games are in a sense saved now.
right.
Um, because goodness knows you can hear our comments about each of these games in that episode that we did. But I mean, I used to love a lot of these. The Bones game on the top right for Walking with Beasts. Oh my God, I must have played that for hours, um, constantly. It was fun, and like doing all the different like difficulty settings, and then kind of honing my puzzling skills in
Yeah.
a sense. Um, just fantastic to hear. I'll definitely be taking a look at these myself. That's great. That's great to hear. Um, and so with that, those are our announcements. And then we're going to jump into our news episodes.
Yep.
Now, again, if you are not in the know with how we do things, in this sort of episode where we have 2 months that we're covering, we are only doing one story each per month. So Albert has an April story, I have an April story, and then we'll have the same situation in May. Uh, Albert has a May story, and I have a May story. And so we're going to start with the April stories, and we'll continue on from there. So
Mm,
we're not going to do like two stories each per month, because then I think we're gonna be here all day. Um,
basically.
so as you can imagine, some of our selection decision making was a little bit difficult because, of course, there's been, as there usually is, a plethora of great stories out there in the past 2 months that we could talk about. We've narrowed it down to some interesting ones. We're really trying to kind of broaden our scope of natural history topics on this show. So we hope you'll appreciate these.
Mm, mm.
Um, but I do believe, Albert, you have first dibs for April.
It seems so, yeah. So let's continue on to that slide then. All right, so for our first story, we are going to talk about a group of extinct marine reptiles called ichthyosaurs, which, as far as I recall, I don't think we've discussed on the show before.
No, I
So,
don't think so.
yeah, they're definitely a really fascinating group. And so, I guess, as a bit of background, as you are probably aware, there have been many types of land vertebrates that have kind of readapted to life in the water. So, of course, all vertebrates evolved from is what we would call fishes. So they started out as aquatic animals, but over time, one group in particular moved onto land and became particularly diverse there, and that is the tetrapods, which are the four-limbed vertebrates. Of course, we are tetrapods too. Um, but many types of tetrapods have since then kind of readapted to life in the water. In some cases, become very extremely adapted to life in the water to the point where they can no longer live on land anymore. And in the modern day, what immediately comes to mind are, of course, whales. Whales are mammals, but their ancestors returned to an aquatic lifestyle, and now they're fully aquatic. And if they tried to come on land and have no way of getting back in the water, they get in big trouble, essentially. And so this transition has happened many, many times among the tetrapods, not only in mammals, but also in reptiles as well. And certainly in the modern day, there are many types of marine reptiles, including sea turtles, marine iguanas, sea snakes. You have things like saltwater crocodiles that sometimes venture out into the ocean. Of course, the many different kinds of seabirds. Birds are reptiles. And we talked a lot about the different groups of marine birds in our series Dinosaurs, the second chapter, so you can check that series out if you want more details on that. But that's just the modern day, or the ones that are still alive in the modern day. And in the distant past, we know that there were many other kinds of reptiles that kind of made this transition back into the ocean. And among these are the ichthyosaurs. And the ichthyosaurs are, in a similar way to whales, one of these marine tetrapod groups that have become extremely adapted to life in the water. They essentially would have had no way of moving around on land. And probably the most familiar ichthyosaurs, if there were such a thing, are the ones that show up mostly from the Jurassic onward. So ichthyosaurs originated, well, at least their earliest fossils are found in the Triassic, and they continue on into the Cretaceous, although they do not seem to have made it into the very end of the Cretaceous. So they are a group of Mesozoic marine reptiles primarily, and seemingly did not make it all the way to the end, but they did survive for quite a long time. Probably the best studied and most familiar ichthyosaurs are the ones that kind of came later from the Jurassic onwards, and these are the ones shown in silhouette form on the bottom of this figure here, where you can see that this is essentially an animal that's shaped a lot like a dolphin or a tuna, probably major fast-swimming open ocean predators. You can see that they have this huge tail fin, essentially kind of torpedo-shaped body, which would have allowed them to swim very quickly through the water. But at this point, they would have lost essentially any capability of moving around on land. Now, for land tetrapods, kind of one of the major challenges of returning to the water is reproduction, because ancestrally, tetrapods that lived on land laid their eggs on land. And if you drop the hard-shelled egg of a typical land tetrapod in the water for too long, the baby is going to drown. And so you can't typically lay a hard-shelled egg in the water. And so marine tetrapods have had several ways of getting around this. Some marine tetrapods, like sea turtles and seabirds, still return to the land to lay their eggs, even if they might otherwise spend most of their time in the water. But there are other types of marine tetrapods that have evolved giving birth to live young. And so, in this way, they're able to spend all their time in the water and, in many cases, don't ever have to come onto land at all. So, of course, this is true of whales. Of course, live birth in whales is not a specific adaptation to life in the water because, as placental mammals, whales already evolved from ancestors that were kind of live bearing to begin with. And so they were, in that way, you could say, pre adapted to a fully aquatic lifestyle. And that may have been true of many of the Mesozoic marine reptiles as well. So ichthyosaurs are one of many groups of Mesozoic marine reptiles that are now extinct. Some other famous examples include things like the plesiosaurs, which are kind of well known for their paddle-like flippers and long necks, even though there are also short-necked plesiosaurs as well. There are also various groups of marine members closely related to modern alligators and crocodiles. Though there are also various groups of crocodilian relatives in the Mesozoic that returned to the ocean. And there were things like mosasaurs, which were a group of lizards, like actual lizards, that returned to marine environments and became apex marine predators, which is pretty cool. So marine reptiles were very diverse during the Mesozoic, and in many cases we're still trying to figure out exactly what type of reptiles some of these groups were. So of course things like mosasaurs, they're pretty clearly lizards if you know lizard anatomy. We know that the various groups of croc-like forms, many of them are actual close relatives to the crocodilians. But things like the ichthyosaurs and things like the plesiosaurs are kind of an enigma as goes their evolutionary history. We don't really have, for example, any kind of Archaeopteryx of ichthyosaurs yet. So we don't know what the ancestors of ichthyosaurs really looked like before they became adapted to an aquatic lifestyle. And we don't even really have like any actual kind of amphibious kind of ancestors of ichthyosaurs, where presumably they would have gone through a phase where they could move around on land but spent a lot of time in the water still. And we don't really seem to have found that just yet. So as far as we know, ichthyosaurs just kind of show up in the Triassic, and we haven't really found any obvious precursors to them yet. And now I suspect some people who are well read about ichthyosaurs might bring this up, so I have to mention this. There is a group of Triassic reptiles that seem to have been very closely related to the ichthyosaurs, called the omphalosaurids. And originally, when some of the more complete specimens of these were discovered, it was suggested that these might be sort of like the amphibious precursors to ichthyosaurs. So these were like early ichthyosaur-like forms that could still crawl on land, but were already primarily aquatic. However, that has been disputed with more recent studies. It seems like even these very early omphalosaurids might have still been, if not completely, then at least mostly aquatic, and in fact might have not even been constrained to just like near shore environments. They might have been like swimming out in the open ocean already. So yeah, it seems that they're not such. They don't quite document that transition as we might have liked. So the origin of ichthyosaurs is still quite a bit of a mystery. And because of this, at least in part, we're not quite sure how they're related to modern reptiles. Like, which groups of modern reptiles are they most closely related to? That's something that we still don't really have a good handle. Now, in recent years, increasingly, more and more analyses are finding that ichthyosaurs may actually be relatively close to some of the other like enigmatic Mesozoic marine reptile groups, like the plesiosaurs, for example. So it might have been that there was this massive kind of radiation of marine reptiles that occurred in or around the Triassic, and just kind of became super diverse in aquatic ecosystems very, very quickly. And so that seems to be the leading hypothesis at the moment, that there was this big marine reptile megaclade that originated either shortly before or during the early Mesozoic. That includes the ichthyosaurs, includes the plesiosaurs, and a bunch of like various oddball forms along with them. But how this big group, if it actually is an actual group, is related to the modern reptiles is still very much a mystery. Different analyses constantly find different results, and partly that's because we again do not have many of the kind of key transitional forms we would expect existed. At least not yet, to document like what the very earliest members of these lineages really looked like. So yeah, an absolutely fascinating group of reptiles. Um, Now, one of the kind of, I would say, most well known aspects of ichthyosaurs, at least ichthyosaur biology, is that they gave birth to live young. And this was something that we've known about for a very long time. Um, like all the way back when some of the earliest ichthyosaurs to be documented by science were discovered. Many of these ichthyosaur specimens were found with embryos inside their bodies. So these are mother ichthyosaurs that died while they were pregnant or while they were giving birth, and these very kind of clearly documented that ichthyosaurs gave birth to live young. And indeed, much more recently, we have found evidence that many of the other Mesozoic marine reptiles gave birth to live young as well. Things like plesiosaurs also gave birth to live young. Mosasaurs, which were lizards, and again not closely related to this megaclade, but they also gave birth to live young. And all of that makes a lot of sense because all of these groups, it seems, don't have any obvious capability to move on land. So it makes sense that their entire reproductive cycle would occur in the water, and they would be probably be primarily live bears. But there is a curious pattern that we see in a lot of these kind of pregnant ichthyosaur specimens, and that is that in many cases, and again this has been documented for a long time, the way that the embryos are oriented in the body cavity, or even like in some of the cases, we can see them like in the middle of coming out of the body cavity when they were preserved. The young, when they were born, seem to have come out of the mother tail first. So they weren't born head first, like we are, but instead they went out into the water with the tail end pointing kind of outward. So, this is pretty interesting because in the modern day, whales also tend to give birth tail first as well. And for a long time, the popular assumption has been that this is a specific adaptation for aquatic life. The idea being that if the young is born tail first, that means it is not in danger of drowning as it would be if the head was out first. And so in this way, with the head coming out last, that protects the young from the risk of drowning, and the young, as soon as it comes out, can quickly swim up to the surface and take its first breath. And that seems to make a lot of sense, right? That seems to be the way whales do it, and we have this documented in these ichthyosaurs. And this seems like a pretty big problem for an air-breathing animal that lives its entire life in the water. So in popular media and in the scientific literature, this has essentially been the leading hypothesis for why these marine tetrapods give birth this way. However, a new study that came out earlier this year has kind of put this into some question. And so what the authors of the study did was that they actually reviewed the current knowledge about how aquatic tetrapods give birth and what do we actually know about the way ichthyosaurs gave birth. Because these early ichthyosaurs that were recognized very early on as being live bearers and that gave birth tail first, these were some of like the later ichthyosaurs that lived in the Jurassic with this very specialized tuna-like body plan. But we know that earlier ichthyosaurs, many of them in the Triassic, did not look quite like this. And you can see this in the silhouettes on here. You see that most of these other silhouettes belong to like earlier types of ichthyosaurs, and a lot of them had this more eel-like body shape with a longer and more slender body shape, and like a tail fin that is not quite as pronounced, for example. And in more recent times, we have found fossils of some of these early ichthyosaurs with associated embryonic remains. Among them is one of the earliest examples is Chaohusaurus, the one on top here. And in that genus, there is evidence that the embryos were not born tail first, but were born head first instead. So that's pretty curious. And remember, we don't have any kind of amphibious ichthyosaur precursors that we know of yet. So even these very early ichthyosaurs, even though they were not perhaps as specialized for open ocean, high speed predation, were still probably fully aquatic, spending all of their lives in the water. But we know that the very earliest members seem to have given birth head first. And the idea was that, well, this was probably something that they retained from their ancestors that still lived on land and still gave birth head first. But very quickly, presumably, they would have evolved the tail first method of giving birth to avoid the drowning problem. And so it was thought that this was just a very early, kind of very brief phase in ichthyosaur evolution, essentially. But since then, even more recently still, there have been other early ichthyosaurs with associated embryos reported, and many of these are closer relatives to the later kind of tuna-like Jurassic ichthyosaurs. And so what do they show? And so that's kind of what this research group centered their study around, was to look at some of these kind of quote-unquote transitional Triassic ichthyosaurs between like the very earliest forms versus the kind of more tuna-like Jurassic forms. And in particular, I looked at three specimens of a genus called Myxosaurus, which is in the middle here, which is a Triassic genus that is known from both China and parts of Europe. And they documented three different specimens with associated embryos, one of which had been reported before in a previous paper, but not studied in detail in this regard. And so they wanted to see, okay, so what's the embryonic orientation in this genus? And what they found was that it turns out Myxosaurus, funnily enough, it apparently seems to have had a mix of birthing strategies. So they found some specimens that seemed to have the embryos oriented tail first towards the birth canal, but others where the embryos seemed to be oriented kind of head first instead. So it might have used both types of kind of birthing methods. And additionally, they mentioned that there's a kind of relatively recently reported specimen of Symbospondylus, another Triassic ichthyosaur, that also appears to have a kind of head-first orientation. And so it may have been that kind of the tail-first orientation evolved relatively late in ichthyosaur history. And it wasn't just like a really brief phase that was kind of a holdover from terrestrial ancestors and it quickly disappeared or was selected out. So yeah, it seems that head-first births are actually quite widespread in the Triassic ichthyosaurs. Technically, the broader group is Ichthyopterygians. And so it's only once you get kind of this more torpedo-shaped body that you start getting a prevalence of tail-first births, it would seem. Now, it's not only that, because it turns out that when the authors looked at kind of birthing methods in a wide variety of live-bearing tetrapods, they found that there was no clear correlation between birth orientation and aquatic habits. It turns out that there are aquatic tetrapods that give birth head first, both today and in the fossil record. And there are land tetrapods, certain types of mammals, for example, that give birth tail first. So there's no clear pattern here in terms of where the birth takes place versus like how the embryos are oriented when they are being born. So yeah, that's in some ways kind of unexpected. And in fact, the authors point out that it is true that the Jurassic ichthyosaurs seem to have preferentially given birth tail first, but there are actually examples known of specimens that seem to preserve kind of a head first orientation in them as well. So it's not a universal thing. And this is also true of whales, too. They point out that there are actually documented records of whales giving birth head first, and no problems occurred in these instances. So it seems that kind of this tail first method of being born is perhaps not, in fact, a specific adaptation to being aquatic. And in fact, it may not be an adaptation to avoiding drowning in the young, because after all, as far as drowning is concerned, as far as breathing is concerned, as long as the embryo is still maintaining kind of a connection through the umbilical cord to its mother, it still has a fresh supply of oxygen. It's only when that connection is severed that kind of the breathing thing becomes a problem. So yes, of course, once the cord is broken, the young has to quickly travel up to the surface to take its first breath. But during the process of being born, while the umbilical cord is still connecting the mother and young, that might not have been such a major concern. So that might explain how many marine tetrapods are in fact able to give birth head first, including whales and including ichthyosaurs. And if you're wondering what are some other examples, they found that sirenians, so the manatees and dugongs, also show a mixture of both head first and tail first births. And there are some various marine reptiles known from the fossil record that appear to have given birth head first primarily as well. So, okay, so if that's the case, why do these later ichthyosaurs and whales show a preference for head first births? Well, the authors suggest two possibilities that remain to be tested by further studies, but kind of alternative explanations for why this might be. First of all, is that if you look at these later ichthyosaurs and if you look at whales, one of the major things that you'll notice is that they don't have a very pronounced neck. So obviously they do have a neck, like they have neck vertebrae like kind of buried deep in their body, but like outwardly, in terms of outward appearance, there is no kind of obvious neck region. Their head just kind of smoothly grades into the rest of the body due to large amounts of soft tissue in that area. So the neck in these animals is not particularly fragile, I guess, while they're being born. So there isn't much of a danger of like the neck being squeezed or like broken during birth or anything like that. So that's one key thing to remember. The other thing is that both ichthyosaurs, especially later ichthyosaurs, and whales have a greatly reduced pelvis. So the hips of ichthyosaurs and whales are highly reduced. After all, they don't need these hind limbs for moving around on land anymore. And so the pelvic region is very, very narrow. And this means that it might be more efficient during birth for the mother to kind of squeeze out the tail end first, the narrower part, while kind of pushing on the bigger kind of head end. And again, because the neck is not very pronounced in these animals, kind of squeezing the head end it is not going to put like the head and neck in as much danger as it might in a longer necked animal. And so this might have been simply the most efficient way for them to give birth to begin with. And another possible reason is that this might be less disruptive to the mother's center of mass while she's giving birth. Because again, the head end is a lot kind of bigger than the tail end in terms of like its width and its girth. And so if you keep the head end of the baby oriented forward towards the mother's front end, that might help her keep her balance a lot better while she's giving birth. Because remember, these are giving birth in the water column, so they kind of have to maintain their position in the water while they're giving birth. And so it might be less tiring for the mother and easier to maintain balance if the tail end is expelled first and the head is kind of kept closer to the front end during most of the process. And so these are two alternative explanations that the authors kind of came up with. But we'll have to see if future studies continue to uphold these ideas as being plausible. But yeah, I thought this was a pretty interesting study because, of course, this is such a long-held assumption. Obviously, as long as I have known about this behavior, the tail first birth in whales and ichthyosaurs, like that's always been the go-to explanation in all the references, books and documentaries and such that I experience, and so it is really interesting to see this challenge, and certainly I do think the patterns that they see in across tetrapods seem pretty compelling. That yeah, this might not actually be a something that's specifically an aquatic adaptation, or at least it's not for the reason that is often given. And so that is pretty neat, and I look forward to further developments on this. So, do you have anything to add?
Well, I certainly agree with you on that. This is certainly an aspect of marine animal biology that I was not familiar with. I didn't know that there were uh, head first births that were documented,
Yeah,
both in life and in the fossil record.
right.
Um, uh, and I didn't really think about the implications of that because, yeah, I guess if the umbilical cord provides all of those um, supplies, as long as it's not severed, like you can have a head first birth to begin with, and it would be like the
Right.
young would be relatively okay.
Mm-hmm.
Um, yeah, that's crazy. Because yeah, my first thoughts were when you mentioned that there was no clear correlation with aquatic habits. I was thinking, well, if these animals are giving head first births, then they must be like hanging out at the surface of the water to do this. But I don't even think we have that sort of data, do we,
Mm-hmm.
for
Right.
like
Yeah.
the live animals that have been documented,
Mm-hmm.
which is yeah, that's crazy. Um, yeah, I definitely would love to see more developments on this because it is certainly something that. Well, I mean, just the fact that this is kind of another one of those things that upends our conventions about animal groups, right?
Right.
You hear the word reptile, oh, they're egg layers, right? Like,
Mm-hmm.
well, no, we have plenty of them that give live birth. Not even just these specialized aquatic
Yeah.
ones. I mean, uh, boas and pythons,
Mm-hmm.
or is it just boas?
Oh,
Boas give live birth.
yeah. Pythons lay eggs. Boas give live birth. Yeah. Mm.
That's it. Yeah, yeah. So I know those are often confused.
Yeah.
Um,
Mm.
and I know there are other types of lizards that do the same,
Mm-hmm.
uh, but it just kind of goes to show like that like there is no typical reptile when you factor in like the fossil record.
Yeah.
Um, you look at animals like these, and uh, they're so derived in their anatomy from what we see today. Uh, I think Mark Whitten put it best in one of his books that modern reptile diversity, for as many species as there are, is very impoverished in terms of just like the amount of phenotypes that have
Mm.
occurred in the past. And, there were not even just not even factoring in birds, of course, but
Right.
there are so many ways of being a reptile that we've discovered. Um, it's almost remarkable what we've lost, and I think ichthyosaurs represent a great example of that. Just a superbly adapted animal
Yeah.
that is just so streamlined in the water. It must have been graceful to see in life.
Mm-hmm.
Um, and they were also like some of the first fossil animals that we really like were understanding scientifically,
Yep.
weren't they?
Yep.
Like, and from relatively complete specimens too. Um, Not always perfect though, because you look at like the historical reconstructions of ichthyosaurs from like the very beginning, like the 1800s. They weren't far off from a
Yeah.
lot of these basal forms that we see on when you think about it, because we didn't have the skin impressions yet that showed the tail fins or the
Right.
dorsal fin. Um, so we've as long as ichthyosaurs has been around as long as paleontology, it
Pretty
seems.
much. Yeah.
They're really incredible animals. Thank you for sharing this study. This is really neat. Yeah, I'm definitely curious. I'd love to see more studies like this with other groups.
Mm-hmm.
Like, I kind of want to see the data that we have on whales. Like,
Yeah. Mm.
what's that about?
Yeah.
Very
That's
cool.
that's a good question. So I'm not super familiar with the whale fossil record, but I do know that there are stem whales um, that have been preserved with embryos, and in particular there are some that are whales that still have kind of legs and feet basically. So
Hmm.
there's one called a Myocetus, the mother whale. Specifically, it was named because of this. It was preserved with embryos, and that one was also preserved with the embryonic orientation, suggesting that it gave birth head first. And the suggestion was that this stem whale probably was still able to come onto land to give birth, and in fact, it was argued that I think that it had to do this because it was giving birth head first. But with this study, I guess that's also kind of put into question, isn't it? It might have not necessarily have been the case for that species either. So, I think this definitely will require some reassessment of a lot of these fossils in other groups too.
Yeah, that's a good point. I remember hearing about one of these stem whales, Ambulocetus,
Mm-hmm.
where I think it's believed now that the animal could not support its weight on its limbs on land,
I've heard about that.
like
Yeah.
standing up.
Right.
And so like that would certainly have implications for behavior like this
Mm-hmm.
if ever we find embryos of Ambulocetus in particular, or
Yeah.
at least animals like more derived than that.
Mm-hmm.
Um, that's incredible. Um, yeah, very good. If you don't have anything else to add, we can move on to our next April story,
Sounds good.
um, the one of mine that is, and so this kind of turned out to be a fun situation. So this April news story that I chose is gonna kind of blend seamlessly into my May
Mm.
news story. And there's also the fact that both of the studies that I chose for this episode are review papers that also add new information to their respective areas.
Mm.
So in this case, this first paper by Costanza Peña Queiroz and colleagues was an attempt to bring some light into the evolutionary history of pollinating insects. While we have much data on modern insects, certainly, I mean, they represent the overall majority of pollinators on the earth, it seems.
Mm-hmm.
There have been some difficulties in understanding how exactly that situation arose. And this is mainly down to two things. How should a pollinating insect be defined? And how would paleontologists recognize
Mm.
that a fossilized insect was a pollinator based on that definition? You might think it strange that we have to define a pollinating insect in the first place. I mean, considering how well known they are nowadays. I mean, we see bees and butterflies and beetles in our gardens all the time, don't we? Well, botanists and entomologists recognize that insects pollinate both angiosperms, so that's the flowering plants, and gymnosperms, so that's conifers and cycads and sort of naked seed-bearing plants. And they do so by transferring pollen grains into the plant's reproductive organs. If you're a flowering plant, the pollen would enter the stigma. But if you're a gymnosperm, there is no stigma. So you have to have the pollen be germinated in a sort of special, what they call a liquid pollination drop.
Mm.
Um, well, I mean, that's just it. It's easy enough to observe these behaviors with living animals, but fossilization doesn't exactly show such details.
Mm-hmm.
You have to rely on other indirect means to find potential evidence of these interactions. And this is where the team came in. So they tracked down as much published literature as they could on pollinating insects alive today and in the fossil record using special keywords. And they listed any and all clades, or in this case, families, that they found, along with some statistics like the geologic age or geographic range of the fossils concerned. Now, as fossil specimens go in this case, they had the benefit of either insects trapped in amber, like this extinct fly shown below. This is from a family, Zangsalvidae, which is no longer around today, as well as those like traditional fossils that are compressed into the rocks. So this shown above, this is a calligrammatid, which is a relative of the lacewings. In terms of what could be observed in such fossils, the team narrowed down their definition of pollinating insect into roughly 5 criteria. So one, an insect must have pollen grains attached to organs used for contact with a plant's reproductive organs. Two, it must at least belong to a lineage alive today that engages in pollination either exclusively or partially. And while these first two criteria are considered the most important, to be safe, the team also looked for three, evidence of a proboscis, or a feeding tube, for feeding on nectar or pollination drops. So not a piercing proboscis, as where this organ probably originated from. For the presence of other morphologies that imply pollination, so structures for carrying pollen, as bees do, for example. And lastly, five, evidence of coprolites in the anal region that have pollen grains inside them. Now, for some insects, the team argued, just being classified in a clade that is today composed of nothing but pollinators would be enough to include it as such,
Hmm.
even if none of the above criteria are displayed, because then the burden would fall on researchers to prove that they were not pollinators. But all of the cases, however, were met with close scrutiny by the authors, as there were possibilities, for example, of insect pollinators that are outliers to all the others in their group who do not pollinate. And of course, when examining remains of pollen, it was also important to check to see if the grains themselves were from plants that require pollination. For example, wind pollinated plants have pollen of a different morphology than those of animal pollinated species. So there was quite a lot to examine for this study. So, in total, the team were able to recognize at least 193 living clades of insects within 10 larger lineages, or orders, including the familiar Hymenoptera, so that's the wasps, the bees, and the ants and their kind, Lepidoptera, that's the moths and the butterflies, and Diptera, which are the true flies with paired wings, as familiar examples. But there were also lesser known pollinators to a lot of people. So earwigs and cockroaches and thrips. Thrips are kind of fun. These are very tiny insects with kind of feathery wings um, that you probably aren't used to seeing because they're so tiny, but they're quite prevalent.
Hmm.
So in their literature search, when they applied their aforementioned criteria, the team had recorded about 54 clades of pollinating insects within 13 higher lineages. So this was represented by 15 clades within about 6 orders that were definitely pollinators, 32 clades from 9 orders that could at least be presumed to be pollinators, and about 7 lineages that were undetermined or could not be really classified. And all this data was then plotted chronologically and within a phylogeny, as seen in the graphics to the far right. So the team were able then to give a rough outline of the history of insect pollinators with a few clarifications. So insects were engaging in pollination with gymnosperms at least as early as the late Jurassic period, so about 163 million years ago. But there are some remains that are possibly going to bring that further back to at least the early Permian period, so about 276 million
Hmm.
years ago, as those insects preserve the long, non-barbed proboscis and attached pollen grains that are characteristic of gymnosperm pollinators. But there's still some discourse about that. Those fossils have to be re-examined. Um, but regardless, this shows that pollinating insects had evolved long before the earliest flowering plants, or at least early Cretaceous in origin, around 125 million years ago. These early pollinators of plants like cycads, netums, and cycadioids include the beetle, thrip, fly, and neuropteran lineages. And so, with flowering plants and the so-called angiosperm terrestrial revolution, we see shifts in attention from different insect pollinators from these gymnosperms to the flowering plants. It had been hypothesized that angiosperms evolved nectar that was more sweet and nutritious than the gymnosperm's pollination drops. And this attracted more groups of insects to switch their host plants. And indeed, in the fossil record, we actually do find evidence of those sorts of switches, at least among beetles, scorpion flies, and early bees. But it's not until the Paleogene period, following the KPG event, that the fossil record provides even more evidence of angiosperm pollinators like wasps, bees, and butterflies. Indeed, you can see in the phylogeny at the right that in terms of sum totals, more insect groups are pollinating flowering plants than not. So these orange squares represent clades that are flowering plant hosts. The blue squares are those that are only hosts of gymnosperms. And then those with both colors host both types of plants. And so, yeah, the flowering pollinators are really holding out on top here. So the team for this paper hope that more questions can be answered by their data, which will inevitably involve going back to fossil and amber sites or finding new ones, and looking for specimens which, when using the criteria provided, can show whether they represent pollinators. In fact, a key question that will be needed to clarify the angiosperm terrestrial revolution and just how and when these jumps from gymnosperms to angiosperms may have happened. Because we find evidence of insects kind of pollinating both types of plants, but we want to figure out like, what sorts of adaptations were they using to do so and kind of where that was going on. And of course, in comparing events in the fossil record, we can anticipate changes occurring now and in the near future as anthropogenic environmental changes are certainly going to affect pollinating insects to significant degrees. So I thought this was a very fascinating paper. What do you think, Albert?
Yeah, absolutely. I mean, pollination, like this kind of ecological relationship between plants and insects primarily, although there are other types of animals that pollinate too, it is just such a key part of our modern ecosystems. And there's just so much kind of really interesting evolution that's been driven by this relationship that I think any insight that we can get regarding on how it originated or how it manifested itself earlier in time is pretty much always really fascinating.
Yeah, I mean, just the antiquity of insect pollination is interesting because I know a common factoid that I see around here, because here in the South, in North Carolina, we have a lot of magnolia trees, and magnolias are pollinated primarily by beetles, because magnolia trees predate the evolution of bees and butterflies, as I understand it. So the only pollinator, well, some of the few pollinators around that could work with those plants are beetles. And the fact that they've just kind of kept that relationship throughout all this time is kind of remarkable and an interesting kind of case study for kind of the deep time of insect pollination. Yeah, magnolias, those are some of my favorite flowers. If there was ever a news story about magnolias, I'm sure I'd be happy to talk about it, but none's ever really come up.
Right.
Of course, botany's kind of a blind spot for me anyway. But I'm trying to fix it. But yeah, once again, I mean, like review papers like this are really fascinating. And when we jump into our May stories, and I do my second story for May, we'll be kind of picking up where we left off in a sense with this paper.
Right.
But for now, unless you have anything else to add, we can jump to your first and your final story for May.
Okay, yeah, sounds good to me. So it turns out that my May story is it's not going to be about insects, but it is another review paper. So some parallels there. But instead of insects, we are going to be talking about kangaroos for this segment here. So I think this is a pretty interesting article. Kangaroos are incredibly distinctive animals today, I think. I think you picture like a kangaroo in your head and potentially what it's doing. There's no other kind of living animal that's quite shaped like that. You have some hopping rodents and such are kind of similar, but other than that, like kangaroo has such a distinctive silhouette. You know it when you see it, and of course, one of the trademark behaviors of kangaroos is their hopping, and very specifically, their high-speed endurance hopping that is practiced by the large kangaroos of today. So This paper, I think the title of this paper is pretty funny, and it does not surprise me who wrote it. So the first author of this paper is Christine Janis, who is a professor at the University of Bristol. And I was actually taught by her while I was doing my master's at that university. So she essentially taught part of our vertebrate paleontology course, and she covered the mammal portion of the course essentially, because she's a specialist in mammal paleontology. And Christine's papers are always very, very interesting, I think. But they often also have kind of a bit of a humorous act to them as well. Because the titles are often very clever. And so the title of this paper, at least the main header, is The Myth of the Quantus Leap. And so, of course, that is a pun on quantum leap. But the term Qantas specifically refers to an Australian airline called Qantas, and their logo is this kangaroo making this flying leap. And so, of course, you can immediately recognize that's a kangaroo, and it's doing a thing that we know kangaroos, or rather, kangaroos are known for doing. Um, but the point of this paper, essentially, and this review, is to point out that this is actually not the only way to be a kangaroo, essentially. In fact, this is a very, very specialized kind of behavior that, across most of kangaroo diversity and across most of kangaroo evolutionary history, has not been their main method of locomotion. This, you know, very long distance, high speed, kind of long distance hopping on two legs. That is something that the kangaroos that we are most familiar with, the big ones like the gray kangaroos and the red kangaroos, that's what they often do, it's true. But the range of locomotory behaviors in kangaroos and their close relatives is actually a lot more diverse than we tend to appreciate. And so technically, we're referring to the group Macropodiformes here. And in fact, a lot of the time when people want to talk about like kangaroos and the close relatives in general, they'll use the term macropods, which means big foot. And you can probably guess how they got their name because the foot of a kangaroo is very, very long. Now, this is a very handy term to use, but the thing is there are multiple clades here that are nested within each other that have the term macropod kind of embedded in them. So there's the biggest group that's Macropodiformes, including all these kind of kangaroo-like forms. But if you can read the phylogeny on here, there's also like Macropodoidea, there's Macropodia, there's Macropodinae, Macropodidae, and Macropodini. And so I guess the term macropod can be a little bit ambiguous if you're just using it like that. So when I'm talking about this paper, I'll try to use kind of more specific terms to make it clear like which group we are talking about at the moment. But yeah, if you look across all macropodiforms, all the kangaroo-like marsupials, you'll see that kind of this high-speed bipedal hopping is not the only way they get around at all. Now, pretty much almost all living macropodiforms can do short-range bipedal hopping, so they can do the kangaroo hopping across short distances. They don't necessarily use it for like very long distance travel like the big ones do, but pretty much all of them can do this can do that behavior. However, that is not the only behavior that they use. Many types of macropodiforms also spend a lot of time, especially when they're not in a hurry, moving around on all fours, so kind of quadrupedal walking. There's a very interesting behavior that a lot of macropodiforms use, especially the big kind of specialist hoppers, and that is pentapedal locomotion, five-limbed locomotion. And you're like, okay, so where do they have five limbs? I thought kangaroos only have four limbs. Well, and that's where their tail comes in. So a lot of the big kangaroos, when they're moving around slowly, and they're not in a hurry to get anywhere, instead of hopping, what they'll do is they'll kind of prop themselves up with their tail during part of the movement cycle. So they'll kind of use the tail propping as an opportunity to lift their hind legs off the ground, both their hind legs simultaneously, and they kind of shuffle forward like that. And so they have this five-limbed gait when they want to move slowly. So that's a very curious kind of a locomotory style. That I can't really think of any other mammal that does that. So it's a very kind of distinctive method of locomotion among the kangaroos. And there are also kangaroos that can do bipedal walking. So instead of moving both hind legs together, they can actually like walk like we do, just striding along. And there are also kangaroos that can climb. So this is best known in the aptly named tree kangaroos, which are primarily arboreal, so they spend a lot of time in trees. And in fact, they're the ones that do a lot of the bipedal walking as well. So a lot of time they want to walk along the top of a branch, for example. They will actually get up on their hind legs and just walk along. There's video of this. It's actually kind of uncanny looking. So as you can see, there's a lot of variation in how kangaroos get around today. Now, how did the earliest macropodiforms move? According to the fossil record, and also based on observation of the living species, probably ancestrally, the fastest gait that macropodiforms would use was not bipedal hopping, but instead quadrupedal bounding. So they're kind of bounding along on all four of their limbs. So if you're familiar with how like a rabbit moves, for example, it would be something similar to that. So they'll push off with both of their hind limbs at the same time and then land on their forelimbs, touching the ground first, and then kind of swing their hind limbs forward and then push off again after that. So it's kind of quadrupedal bounding using all four of their limbs. And this is something that is seen in at least one living species, and that is the musky rat kangaroo, which is a very interesting species. So it's like the most distantly related to all the other macropodiforms that are alive today. And it's a very it's a pretty small animal. Has a kind of long naked tail, a little bit like a rat's tail. So I guess rat kangaroo in that regard is not too bad of a descriptor. And it primarily uses this kind of quadrupedal bounding behavior when it wants to move quickly. It can also climb a little bit, so that's interesting. But yeah, that's like the one living macropodiform that does not do much kind of bipedal hopping. But it seems that bipedal hopping did evolve pretty early on in the macropodiforms because all the other ones that are alive today do it. And looking at various fossil macropodiforms, they exhibit kind of a wide range of locomotory behaviors as well, including pretty much all the ones that we just described earlier. Now, when it comes to long distance hopping, that is something that probably originated in the group called Macropodini, the macropodins specifically. And so the macropodins include basically the most familiar kangaroos, so things like the red kangaroos and the gray kangaroos, and also most of the forms that we call wallabies. And specifically, it's actually like a group within the macropodins that really kind of specializes in this long distance hopping that we are very familiar with. So the macropodins are essentially like this the group colored in deep purple on the bottom of this phylogeny here. And so there are a few members of this group that aren't like long distance endurance hoppers just yet. So like Cetonics, for example, is the quokka, which is kind of a small wallaby, but that doesn't really use like this kind of long distance travel method. But as you get like kind of closer to the big kangaroos, you start seeing more of these groups that are kind of major endurance hoppers that do kind of adopt the travel method symbolized by the Qantas logo, essentially. And it kind of makes sense that kind of long distance hopping originated in this group because first of all, this is a group of kangaroos that have specialized for grazing behaviors, so kind of feeding on grass essentially. So a lot of these kangaroos live out in open habitats and they feed on grass that's close to the ground, and often have to travel for long distances across these very arid environments. And in fact, kind of a very classic hypothesis for the origin of this endurance hopping is that like kind of these kangaroos are the culmination of specialization into a specialization kind of correlated with the increasing aridity of Australia throughout the Cenozoic, because much earlier in the Cenozoic, Australia was a lot wetter than it is today. So a lot of these early kind of quadrupedal or short distance bipedal hoppers were forest dwelling animals, and in some cases still are today. But as kind of habitats opened up and the conditions became drier, the classic hypothesis was that there was this major selective pressure to become kind of long distance hoppers among the kangaroos, and kind of culminating in the kind of big kangaroos that we see today. And the kind of body size that they reach is also significant too, because the big kangaroos today, the gray kangaroos and the red kangaroo, they probably have like essentially the optimal body size for this kind of locomotion, for endurance hopping, because basically they have a lot of energy saving adaptations that like in their ligaments and their tendons, that when they hop, even if they hop like even if they accelerate, even if they increase in speed while they're hopping, they don't spend more energy. So that's a very cool adaptation. So they can just keep going and going and going, and at like quite high speeds too, without like getting too tired. And so that's an incredibly useful adaptation if you need to travel across distances in an arid habitat. But if you're a much smaller animal, you can't really get that spring basically, like you just don't have like the body mass to maintain that, and so you don't get the benefit of kind of that energy saving if you're trying to travel for a long distance like that. So in much smaller kangaroos, things like the rat kangaroos, and things like the smaller wallabies like the quokka, like they don't typically use kind of endurance hopping like the big ones do. However, if you get much bigger than the big living kangaroos, you essentially become too big to hop. Basically, like like your body mass becomes too high that hopping no longer kind of is no longer efficient for you. Having to move so much body mass around in that way is no longer such a good strategy. And so it seems, it has been suggested at least based on these kind of biomechanical grounds, that the big living kangaroos have kind of reached the optimal size for endurance hopping. If they were much smaller or much bigger, it wouldn't work out so well for them. And so again, this is one of the things that has caused kind of the formulation, or kind of promoted the formulation of this classic model that kangaroos kind of underwent this very strong selective pressure to become long distance hoppers with the increasing aridity of Australian habitats. But it turns out that this is something that's a little bit biased by our modern diversity of kangaroos, because the authors of this paper point out that during the Pliocene and the Pleistocene, there were other big kangaroos around that probably did not use this endurance hopping method. They give a couple of examples here that are known. So one is a group of extinct kangaroos called the Sthenerines. And so the Sthenerines include the biggest kangaroos that we know of all time. And they could get much bigger than the biggest living kangaroos today. Now again, remember, if you get much bigger than the biggest living kangaroos, hopping is not as efficient anymore. And based on this, as well as on anatomical grounds, and recently at scientific conferences, people have also reported trackways that support this. It has been suggested that Sthenerines, at least the really big ones, did not hop, like pretty much at all. Instead, they probably used bipedal striding. They were walking a lot like we do. Like they were putting like one foot after another while they were walking around. And so I would imagine that must have been a very uncanny sight to the first humans to have arrived in Australia. Because, you have these like massive bipedal creatures, like bigger and taller than you are probably, just walking around and looking really weird and probably not much like anything else you've ever seen before. It's hard to imagine what these things would have looked like. I know, like if you look at photographs of big kangaroos today, a lot of them look pretty uncanny. Like kangaroos are really muscular animals, and so if you look at like a lot of the big individuals of kangaroos, they're basically ripped, and so if you imagine like something even bigger than an extant kangaroo, and it's just got this weird I don't know, vaguely rabbit-like face, maybe, and kind of walking around on these long stilt-like legs. Something really weird about some of these kangaroos is that they essentially had only one toe on each of their feet, like their hind feet. So yeah, like they were walking on like one toe at a time, basically. So in that sense, kind of like horses, I suppose. And that all that together, I mean, these animals are really really weird. So yeah, you had these bipedal walking sternurines probably. Incidentally, one of the main papers that proposed this kind of bipedal walking locomotion in sternurines was also co-authored by Christine Janis, and I think that paper had the title "Hopless Monsters." So there you go. Yeah, she always comes up with really memorable paper titles. I love it. But so that's really curious. And there were another group of kind of kangaroos that reach large body sizes, and that those were members of the genus Protemnodon that also lived from the Pliocene to the Pleistocene. And Protemnodon is interesting because it's actually nested within this macropodin group. So they would have evolved from ancestors that probably did use endurance hopping like the modern big kangaroos do. But it seems that when they got bigger, beyond that size threshold where hopping was advantageous, they stopped doing this. And in fact, there is anatomical evidence that large species of Protemnodon primarily used quadrupedal kind of movement, so they were probably like walking around on four legs most of the time, which is pretty interesting. It's thought that they might have still been able to move around on two legs sometimes, but they do show like specific adaptations for kind of quadrupedality, and so that's why they say that they are probably facultative quadrupeds in this paper, meaning that they can switch between both bipedal and quadrupedal options, but probably most of the time they were primarily quadrupeds, which is very interesting. And so in light of this, you even have like this genus that went from endurance hopping ancestors to kind of a quadrupedal gait instead, which suggests that, well, no, like endurance hopping was not the only way to be a kangaroo in these changing Australian environments. There were many other ways of getting around if you were a kangaroo in the Pleistocene. And it is only because that these big Protemnodon and sternurines have gone extinct since then during the Pleistocene megafaunal extinction. So that's come up again. That we only have like the only big kangaroos that we have left are these endurance hoppers. And it's true, endurance hopping is a very, very useful adaptation for living in arid environments. But it does seem that it's not as straightforward as people might sometimes portray it as. It's not that arid environments only favored kind of this type of locomotory method, because clearly the sternurines and things like Protemnodon were still doing pretty well, and in the case of Protemnodon, even like kind of lost the ability to endurance hop. So that is I thought that was a pretty cool kind of overview of a very underappreciated element of kangaroo biology. So I've mentioned before that there's this, I guess, kind of entertainer, singer, songwriter who goes by this stage name, Professor Flint. He's written a lot of songs about Australian paleontology, including one song about Protemnodon and Procoptodon, which is one of the biggest sternurines. And in the song, he describes them hopping around like modern kangaroos would. But I think in light of this new information, we might need to get a different version of the song from him now. It turns out that these big kangaroos were doing some very different things from the modern ones. And so finally, I leave off with the final sentence in this review paper, because I thought this was just something really funny that they inserted in there. So I quote, and this is on the bullet point, on the last bullet point on the slide here. We are perhaps then in need of a rival Australian airline that covers shorter distances and quantas and boasts a novel motif of a striding sternurine. That would be pretty cool. one final thing that comes to mind that is not really related to kangaroos, but it is interesting to note, and it is related to paleontology, is that there is a fossil dinosaur from Australia that's named after Qantas. So it is called Qantasaurus, straightforwardly enough. Yeah, it's one of those kind of small ornithischian dinosaurs, the quote unquote bird hip dinosaurs that kind of probably ran around on two legs. There are a lot of those types of dinosaurs known from Australia. And yeah, one of them is named after this airline. So yeah, it turns out that this airline perhaps has more connections to paleontology than you might expect. But yeah, anyways, do you have anything to add about this review on kangaroo locomotion?
Well, a couple of things. First and foremost, Christine Janis sounds like a pretty awesome person. I'd love to pick your brain a little bit.
Yeah,
Um, but gosh, yeah, stenourines. Yeah, like I remember hearing a little bit about that research recently about how they were kind of walking around like one foot in front of the other.
right.
Um, gosh, it is just so uncanny. I'm kind of joking a little bit, but I'm looking at the silhouettes here on
Uh-huh.
this chart. You sure they didn't take like a Carnotaurus and just put bunny ears on it or something like
Right.
that? Because that is just wow. Yeah, I imagine the First Nations people who first arrived in Australia probably having a field day with all of these giant strange animals running around. I
Right.
mean, between the human roos and the giant wombats and the giant monitor lizards and
Yeah.
snakes and birds.
Yep. Mm.
Gosh, you think Australia is crazy now? I mean,
Yep.
40,000 years ago, it's pretty crazy then too.
Oh, yep.
Um, well, one of the things that strikes me is interesting, and this is coming from a paleoanthropology perspective, regarding this paper, is just how kind of closely this new kind of review summary parallels what we've been learning about hominin
Right.
bipedalism. Because that traditional like savanna hypothesis that walking out in the open made us bipedal, that's been put to bed
Right.
pretty much. Um, and so kind of seeing that here with kangaroos, where that idea that they became like efficient like endurance hoppers just because they went out in the open, like seeing that kind of put to bed too.
Hmm.
It's an interesting parallel.
Right.
Hearing about like the probably quadrupedal bounding ancestors of these kangaroos is not all that different from some of the ideas we've been getting about the earliest hominids, how they
Hmm.
were these kind of suspensory quasi bipedal apes
Right.
that were still heavily utilizing the trees even until relatively recently in
Hmm.
hominin evolution. And even when like the land began to open up and there were savannas and grasslands everywhere, like even as more of these hominins were moving out and becoming more efficient bipeds, they were doing it in different ways. Just based on some of the biomechanical studies we've been doing, we're finding hominins that are like striding in different ways. The way that they kind of hold their feet to the ground is different. Like they put weight on different parts of the foot, um, and it's interesting to see like that sort of like that complexity among hominins, and
Mm.
certainly among other animals too during that transition period when kind of the grazers and the pack hunters were taking over the world, right?
Yep.
That's sort of a very iconic image in the history of mammals, um, because the spread of grasses, while not simultaneous, did happen during a relatively short window of time as the climate of the Earth was cooling. So it's interesting to see kind of how kangaroos respond to this sort of thing
Yeah.
by all of their different ways of bounding and moving and walking. It's interesting because yeah, like as far as marsupials go, a kangaroo is kind of a stereotype among
Yeah.
marsupials. It's like when you hear marsupial, it's either that or a koala,
Hmm.
which of course masks a lot of diversity in that group as well.
Yep.
But like even a term like kangaroo, a study like this will show you like, oh well, that's even thinking of a kangaroo as just like the big hopping ones, like the red kangaroo
Yeah.
or the western gray, is underplaying just how many different ways there are of being a kangaroo,
Hmm.
both now and in the past. And, yeah, I appreciate studies like this. I definitely want to get more familiar with Protemnodon because that's one that I haven't really read about much.
Mm. Yeah. Mm.
Um, Usually in these kind of like well, in books about the Paleolithic, when they talk about the megafauna, they always mention Procoptodon at least.
Right.
Um, but Protemnodon is usually kind of put put on the wayside. They don't really mention it at all, because it doesn't even exist.
Right.
But to see kind of like a giant, like facultative quadruped um, kangaroo, like coexisting with these other forms, like that's in many ways like that's almost as weird as a striding like Procoptodon, you
Right.
know,
Yeah.
because that does not match our platonic ideal of
Mm-hmm.
what a kangaroo is supposed to be. So
Mm-hmm.
um, it's remarkable. Yeah, man, you mentioned the tree kangaroos earlier too. That's another group that
Yes.
is fascinating. Yeah, and they are one of those mammal groups where like until relatively recently we've been finding new species
Yep.
um, in the forests of New Guinea and the
Mm-hmm.
like.
Yep.
Fascinating island. But yeah, that sounds great. Fantastic paper. And if there's unless there's anything else you want to add, we can move on now to our final paper.
Oh yeah, take it away.
Sure. So this is my May story, and again, we're kind of picking up where the last paper left off. This time focusing on just one lineage of pollinating insects, the butterflies. Now, despite their worldwide popularity, including probably being the only insects that are like near unanimously not hated,
Right.
um, which is a shame.
Yeah.
Um, Butterflies have remained poorly understood as regards their evolutionary history. True, there were previous studies that have analyzed their phylogeny, and we do have fossils going back at least 55 million years. We know, for example, that butterflies can technically be considered a lineage of moths,
Mm-hmm.
albeit ones that became day living and rest their scaled wings up over their backs instead of splayed out to their sides, which is one of the ways that you can tell, quote unquote, a butterfly from a moth.
Mm-hmm.
Um, so this particular clade among the moths, the Rhopalocera, includes two sublineages. So there are the Hydaelids, or the moth butterflies, which are primarily tropical American, and then everybody else in the Papilionoidea, which has divided into a further six sublineages or families. So things like the skippers and the swallowtails and the metalmarks. Basically, any butterfly that you've probably seen belongs to that subgroup. Um, but of course, these sorts of studies have really only scratched the surface of butterfly evolution. I mean, because there's something like 17,500 species of butterflies and
Gosh.
growing. So these studies have not been able to address key questions on things like adaptations to new biogeographic regions and climates or the role of caterpillars in their plant hosts. There's just so many butterflies to parse through.
Yeah.
Thankfully, Akito E. Kawahara and colleagues have kind of come to the rescue. They have produced the largest and most complete phylogeny of butterflies so far, encompassing the gene sequences of 2,244 species, which compared to the 17,000 number doesn't seem like a lot, but it does at least represent 92% of all known genera and all of the known higher clades, save for the Hydaelids, complete with the data on global distribution and host associations. So this is a pretty good start. Um, this tree is displayed rather beautifully to the right for those interested. In the study, the team wished to address three questions in particular. So, in their words, one, did butterflies originate in the northern Laurasia or southern Gondwana hemisphere? Two, what plants did the ancestor butterflies feed on? And three, are host repertoires, that is, diets, of butterfly species and clades constrained by host phylogeny? So, one note of relevance for taxonomists with this phylogeny is that the team were able to confirm many of the historic classifications for the butterflies, including many of these traditional families. Um, but regarding the clades below that, and in the Linnaean taxonomy, these are known as tribes, curiously, 36 of those appear to be in need of revision. as the data did not indicate these represented natural groups. So that's always important to find out.
Hmm.
And moving on to the evolutionary data, so the team were able to place the last common ancestor of butterflies much further back than 55 million years ago, actually to the tail end of the early Cretaceous period, around 101.4 million years ago. These insects, the team deduce, would have been a lineage of nocturnal herbivorous moths, probably akin to something like a hedylid, which is mainly nocturnal and whose caterpillars feed on rosette plants. In fact, the team estimate that these earliest butterflies were specifically feeding on plants of the Fabaceae clade. So that is legumes. So that's pulses, beans, lentils, and clovers, for example, which their phylogenetic studies have shown a common ancestry at least as far back as 98 million years ago. So that's a pretty close enough approximation to that with the
Hmm.
butterflies. And this was something that historical entomologists had proposed in the past, but until this study, that hypothesis had lacked any empirical support. So, where did this butterfly ancestor live? Well, this is kind of fun. Using the biogeographic data, the team were not able to narrow it down to any specific location, but they did provide a sort of kind of small range within an area of Western North America. So anywhere from the area of present day California and Mexico and down into Central America. So, in other words, a Laurasian origin for butterflies was tentatively supported instead of a Gondwanan origin. The latter, of course, is a supercontinent which encompassed South America, Africa, India, Sahul, and Antarctica. It's a fun batch. Of course, when you consider the world map of the early to late Cretaceous transition, you do find that the positions of the continents were approaching their present day locations for the most part. I mean, the location of India was a really serious derivation. It was still pretty close to Antarctica at the time and Africa, um, which would make things pretty easy for the team when it came to projecting forwards in time to show how butterflies dispersed around the world from this seemingly North American locality. So, throughout the next 10 to 30 million years into the late Cretaceous, butterflies had diversified into all their major present day clades or families, especially around the neotropics. So, that is the tropical Americas into South America, coinciding with the end of a change in climate called the Cretaceous thermal maximum, which had increased temperatures and CO2 levels around the world. So once that event had ended and the globe began to cool down somewhat, the butterflies could then disperse to the other land masses. So they reached Sahul first, and then Eastern Eurasia by 75 million years ago, by way of North America, and then to the southeast of Asia and across to India. Now, Sahul in particular, and to refresh everybody, Sahul was the landmass that included Australia, New Guinea, and Tasmania once upon a time, before sea levels cut off those two islands. Well, I guess three islands if you consider Australia an island.
Right.
I know that that's a whole thing. Um, but Sahul in particular was a rich hub for these butterfly dispersals during the later part of the Cretaceous period. So all these butterfly lineages ended up surviving the KPG, with the neotropics remaining, a site of large-scale diversity and evolution throughout the early Cenozoic era, beginning around 60 million years ago. Now, as a rule, speciation in the tropics, is found to be greater than that in the temperate regions. This is a general trend across animals and plants, although the reasons for that have been long disputed. Um, but the team did find some derivations from this, namely that the swallowtail butterfly lineage, the papilionids, actually diversified, they actually dispersed into the neotropics at a higher rate than from within. And incidentally, this is something that was also previously hypothesized, and now we're finding evidence for this. So these sorts of expansions between the tropical and temperate uh, Americas became quite pronounced at the Eocene Oligocene transition around 33.9 million years ago, which was also roughly when the first dispersals to Africa began. And curiously, Europe would remain unsettled by butterflies until as recently as 17 million years ago. And so today, the greatest diversity of butterflies is in tropical America, followed by the Indo-tropics. Europe and Sahul, in contrast, have the lowest diversity of species. Womp womp. Now, turning to larval hosts, to answer those sorts of questions, the team studied their phylogeny alongside a huge literature deep dive. They compiled over 31,000 butterfly host records from books, papers, and databases, both public and private. And it was discovered, in another instance of corroboration, that the origin and evolution of butterflies actually lagged a bit behind that of angiosperms. Of course, we saw a similar instance of that with the pollinating insects as a whole in the April paper that I talked about.
Yeah.
So while the earliest caterpillars seem to have been feeding on legumes, over the next 100 million years, they'd become remarkably host specific. The team found that something like over two-thirds, or 67.7% of all the butterfly species in their analysis, had become specialized to feed on just one clade of plants in the present day, with the remainder, that's about 32.3%, being generalized to two or more clades. Now, of those specialists, the majority of those have preferred to stick with the legumes as well as the grass lineages, as these plants have not evolved the sort of chemical defenses that other plants use to keep insect larvae from feeding on them.
Huh.
And of course, these are also very widespread and abundant types of plants. No doubt the spread of grasslands in the later half of the Cenozoic that we just talked about
Yeah.
was a huge boost for butterfly numbers. And funny enough, even the generalists, it was found, were more specialized than expected. So their caterpillars were choosing hosts from different plants, but they were relatively closely related plants. So, like, a generalist would be feeding on maybe two types of legumes, for example, which is just incredible. And really, like, considering studies of this sort described in this episode, as well as your kangaroo one, where great swaths of data are reviewed and analyzed, and new research is composed from that work, I think these are absolutely crucial for understanding the world around us. I mean, I'm certainly grateful to the researchers who do this work, which must take so many years
Yeah.
and probably was very tedious at times. I mean, goodness gracious, going over 31,000 records on caterpillars or checking the keywords for fossil pollinators on each and every paper in an online database. That's not something that you do willy-nilly. It takes a dedicated team and a lot of effort. So I certainly feel immense joy in being able to share these papers with you all. And I certainly hope that future research will be heavily benefited from them by people who don't have to necessarily do the work a second
Yeah,
time.
right.
Gosh, I'd love to hear your thoughts on this.
Yeah, I mean, I love this type of study, these kind of big phylogenetic analysis. And if you know me, that's not a surprise because obviously phylogenetics is one of the main things that I study. So of course I would say that, but I really do think like phylogenetics is one of the most insightful ways that you can use to understand the living world. If you have a robust phylogeny covering many different species in this way, even if you're not familiar with this group of organisms, that gives you a framework to put like any species within this group, at least those that have been included in these analyses or are closely related reasonably enough to the ones that have been. You can put any of these species into kind of context with the rest of its group. Like, what is it most closely related to? When did these groups originate? And you can like from there gain like kind of incredible understanding of any single species that you ever find yourself being curious about. And I think that's a very, very powerful thing. And just in this one study that you just talked about too, they did a lot of kind of interesting analyses with the phylogeny that they got. So, of course, they got the timeline of evolution of butterflies. They inferred where and when a lot of these major groups evolved, and also kind of how their relationships with plants have changed over time. Those are all very major parts of understanding butterfly biology. If you have a phylogeny like this, you can understand any organism in the world, and I think that's a very, very powerful thing. And so I always think it is great whenever this kind of study comes out on any group of organisms. It's always guaranteed to have some really fascinating insights about the diversity and origins of these groups. And furthermore, other scientists, like you mentioned, can take this phylogeny, can take these results and use them for their own analyses, like maybe analyzing other aspects of their biology, or including even more species, or kind of factoring in like fossil data and things like that. It's it just opens a lot of doors to many different avenues of research, and that's definitely one of the reasons why I am so fascinated by phylogeny, and I think it is so important to understanding kind of evolutionary histories. If you don't have a good phylogeny, like the tricky thing is our evolutionary history, like our as in like all organisms, it is written all over us. Like why we are the way we are is not solely just down to environment, even though that plays a very big part, but also how we evolved and what we evolved from. And so if we don't have that context, we can never get the complete picture of why living things are the way they are. Um, and so that's kind of my soapbox spiel on phylogeny. And for butterflies specifically, I think that they're a great group to look at because yeah, like you said, they're a group of insects that I think most people have a pretty positive impression of, um, and are fascinated by. Because I see butterflies so often, I'm sure like most people spend like any reasonable amount of time outside see butterflies pretty often, and yet I don't really know much about butterflies. I would say certainly not in like specific detail about natural history of most of the different species. Um, I think having a study like this is great for people like me who want to put them into their context with each other, but also for people who are already familiar with butterflies to kind of gain like even deeper insight into their evolution and origins. So that is great, and it is always mind-boggling to me just how many insects there are. I think you mentioned earlier that there are like 17,000 species of living butterflies. I, that is incredible. I like there are lots of people who are interested in knowing like all the birds of the world, for example, and we have about 11,000 species of birds alive today, and so 17,000 is already more than all the birds that are around combined. And I think it's really fascinating too the insights on kind of how their relationships with host plants have changed over time because it sounds from this like indeed like the Cenozoic was probably a really major kind of period of evolution for the butterflies, even though they seem to have originated in the Mesozoic, because like you said, grasses became more diverse and abundant during the later half of the Cenozoic, continuing into the present day, and legumes as well. They also kind of went through a kind of rise in abundance and diversification. In this case, I think towards the beginning of the Cenozoic, like they were among the first plants to recover from the big Cretaceous mass extinction, and so that's really interesting to think about how these events post Cretaceous have impacted insect evolution and given rise to one of the most familiar and most kind of admired groups of insects that share the world with us today. So I'm never not going to enjoy hearing about big phylogenetic studies like this, and I think this study also goes really well with the review paper you talked about on pollinating insect evolution through time. So yeah, that's just wonderful.
Oh yeah, and like it really opens the door for a lot of research and a lot of interesting questions that can come about because what kind of comes to my mind about this is like okay, so the earliest fossils we have being 55 million years old.
Yeah,
Um, if we didn't have phylogenies like this, well, then we would have probably assumed that that's when butterflies evolved, or at least
right.
close to that time.
Exactly.
Being a post KPG phenomenon, right? Um, but if you have a study like this that's showing that all of these different lineages of butterflies were around and made it through the KPG, well, then there's just a bunch of questions that just kind of come out the floodgates with that. Like, how did they survive such a dramatic event compared to other groups of insects? And like, what were they doing? What were their survival strategies? You know, because if they're feeding on legumes, well, then how did the legumes make it through the KPG? Um, yeah, I'm very interested in that. And then, of course, it gives paleontologists a benchmark, right? If you have a rough idea now of the geography of where these butterfly lineages were emerging, you can kind of hone in your efforts to those parts of the world in those layers that are the right time period. And maybe if you're lucky, you'll find like those sorts of key fossils that document that transition. But certainly, fossil remains, depending on how they're classified, can help constrain these sorts of phylogenies somewhat, right? And they can even change how some of the data is interpreted because um, they might shorten or increase the branch lengths
Yep.
between groups of organisms.
Right.
Um, so certainly, this is not going to be the last word on butterflies, and yeah, I definitely anticipate like further improvements and elaborations on this to where more species are included and maybe more specific questions can be answered, like what were the routes that butterflies were taking, how are they able to disperse across continents, even though like at the time like the continents were a little bit closer together in their present day locations, you're still dealing with like large seaways.
Yeah.
um, and so like were the butterflies powering through these, were they riding on thermals and the air plankton that is not really talked about all that much, like the air currents just carrying off so many small invertebrates to and from places to where you have like spider webs above Mount Everest and some crazy numbers like this.
Yeah.
Um, it's a lot to think about. And I agree with you for sure. I mean, I don't study phylogeny, but I am definitely interested in the questions that phylogeny brings. And I'm curious to see what the tree of life looks like.
Yeah.
I even if it means going into like specific groups like butterflies, like it just floors me that we've been able to get to this point with our technology and our resources to be able to draw a family tree of butterflies like this when before taxonomists had you know rather crude methods for trying to figure out butterfly relationships. And even then, like they were working in like pre-evolutionary times, right? They were all creationists for the most part. So it's incredible, and because I love like kind of seeing the results of these sorts of things that you can even get questions about deep time from a phylogeny of primarily living species.
Right.
Because to my knowledge, they didn't sequence, well, they couldn't. They didn't get any data from fossil
Right.
butterflies into this study. This is all living groups, um, and in fact, the majority of the DNA that they got for the butterflies was for the first time in this paper.
Yeah.
So like even like for a review paper like this, like they did a significant amount of contributions to like insect DNA research by just sequencing all of these genes for the first time. For I think it was like over like 1,600 species were for the first time
Right.
sequenced, which is most of the species in the sample,
Yeah.
which is that's great. I mean, that's just another example of how important this work is. So definitely massive props. Akito E. Kawahara and colleagues. You guys did great. Um, but with that, unless you have anything else you wanted to add, that is it for our news stories. Of course, now that we're kind of back into the swing of things, I think we definitely hope to kind of pick up where we left off with our news episodes and continue from there with our singular month coverage, but we shall see. Um, was there anything else you wanted to add before we closed out?
Oh, no, not really. I think you covered that quite well.
All right, fantastic. So let's move on now to our kind of closing slides here. Um, of course, we are on Patreon if you're interested in supporting us. We are patreon.com/time and clades, where your contributions will help us continue the series and develop new projects and expansions. Um, we currently have 4 patrons right now that are of a tier, and of course we have several tiers that you can choose, but any monetary donation would work, where they are owed shout outs. So we want to give a big, massive thanks to Paul, Denver, Frankish, and Valdinunzio for their help with our show. We definitely appreciate it. And of course, we are kind of exploring how we use Patreon now. So as we alluded to in the Doraemon episode, um, we are starting to have early previews of the topics we're going to cover in future episodes. So if you're interested in kind of getting sneak peeks about what we're going to talk about and get the chance to send in questions and like other things that we could maybe mention for those episodes, you are able to do that if you're at our highest tier. But of course, the choice is always yours. And of course, our general acknowledgments. We want to thank our good friends Henry and Alicia for their contributions to this series. Of course, Henry's behind the upbeat music that opens each of our episodes, and Alicia is responsible for the color scheme of Albert's Alvarezsaur avatar. A very cheerful fellow. And of course, we are on Twitter. We are at Time and Clades, where we usually upload and share finished episodes. But most likely, you are watching us on our YouTube page through Time and Clades. So if you want to give a like and a subscription, we definitely would appreciate it. It's up to you. And if you have any questions for the show, whether that be about the topics concerned or anything in general, you have 3 ways to contact us. You can send us an email, timeandclades@gmail.com, or you can send us a comment on our YouTube section, or you can tweet at us, and we'll almost certainly get to that as soon as possible. And of course, if you want to check out any of the papers we've talked about in our news episode, those links are in the description, as well as anything else that we've mentioned. For example, the archived Flash games. So if you want to go to that website, we'll have that there too. And anything at all that we've mentioned, books and whatnot, we will put that there for you. But with that, that is the end of our show. And of course, like what a time to be recording, because as of the time of recording, it is the summer solstice. It's the
Yeah.
longest day of the year, at least in our hemisphere. Uh, so I hope you all are enjoying the start of summer and the hopefully not so scorching hot times ahead. We shall see. Spring's already been kind of hot here and there,
Yeah.
so that's kind of easy. Um, but of course, if you're looking forward to the future of the show, again, we will most likely be doing a June episode here real soon. But of course, time will tell. Um, as far as like other episodes down the line, possible reviews, well, we shall see.
Indeed.
We're always communicating and coming up with ideas, so sometimes you'll never know what to expect.
Right.
But we're sure you'll be there to join us, and we appreciate that. So we hope you all have a very wonderful day. Thanks again for joining us.
Yeah. Take care, everybody.